In today's video, we are going to solve a Leetcode problem 909, snake and ladder problems. This is a very interesting problem, and I think you have already gone through the statement, but still, you pause this video, go through this, and let me begin snake from and here. Ladder. So this is a classic breadth first search based problem, and we are going to distinguish as a board game, and we will break it down step by step, and we'll go walk through the clean Java code, and let's roll in. So what is given here, let me read for you. So you are given a n cross n integer matrix board where the cell are labeled from 1 to n square, right? Means like this you have seen in your life when you are playing the Ludo in your childhood, right? So this is like that, and that is called this style, and starting from the bottom left to the board, board is n-1 and 0, and alternating the direction each row. You start on square 1 of the board in each move. Starting from the square current, do the following. What we need to do the following: choose a destination square next with a level in the range current plus 1, and we'll take a mean of current plus 6 or n square. Either you will take current plus 6 or n square, right? Which one is the minimum that you have to choose? Means the range will be current plus 1 and current plus 6, minimum of current plus 6 or n square. Which one is the minimum that we will take, right? Means we have to choose a destination square next with a level in the range of current plus 1, and then we have to take the minimum. This is the left bound, and this is your right bound. So right bound will be current plus 6 or n square. Which one is the minimum? That will be your right bound. So you know the range, right? The range between left and right is called the range. So this is left bound and this is your right bound. I hope you understand, right? Let's understand further. So this choice simulates the result of a standard six-sided die roll. That is, there are always at most 6 destinations regardless of the size of the board, right? If the next has a snake or ladder, you must move to the destination of that snake or ladder, otherwise you move to the next, right? If next has a snake or ladder, you must move to the destination of the snake or the ladder, right? From the snakes comes or ladder happens, right? You remember, right? Let's suppose this is the destination, right? If we take the snake, right? So a snake, where the snake will go, that we will see, the destination will see, and this is the ladder where the destination will go, right? That we will see. If the snake is coming, if you are going here, let's suppose for 17, right? You will go back to 13, right? If you are going, if you are getting the ladder, right? 14, you will go to 35. Like that we have to do. I hope you understand this game, right? Otherwise you move to the next, right? Otherwise you go to the next. If you are not getting the snake or ladder, you will move to the next. The game ends when you reach the square n square, right? The game when you reach the n square, right? Let's suppose you start from 1 and you reach to 36. Means how many cells are there? So in the row you see 1 2 3 4 5 rows is there, 6 rows is there, 1 to 6. So 6 into 6 is 36. So if you reach to 36, means you reach the game, you have reached the square, right? Means the game ends when you reach the square n square. Now it is saying that a board square on row R and the column C has a snake or ladder. If board R and C not equal to -1, the destination of that snake or ladder is board R or C. Square 1 and n square are not the starting point of the any snake or ladder. Note that you only take a snake or ladder at most once per dice roll, right? If the destination to the snake or ladder is the starting of another snake or ladder, you do not follow the subsequent snake or ladder. For example, you suppose that you have given this board -1 4, -1 3, and the first move your destination square is 2, right? So you follow the ladder to the square 3, but you do not follow the subsequent ladder to 4, right? So we have to return the list number of dice roll required to reach the square n square. It is not impossible, right? It is not possible to reach the square, return -1. Okay. So I'll suggest just pause this video here and go through the statement again, and then we'll go through the example. The statement is saying that it is saying like we have given a n cross n matrix, right? First of all, and it is filled with the numbers, and that is called Bostrom style, right? They have given. And this Bostrom pattern means the direction of leveling zigzag row by row, right? This is a zigzag row by row. Okay, and you start at square 1 and you move, each move you will do, and you will roll to six-sided dice, right? Means this we have given, right? So we have to start from 1, right? You have to start at square 1, and for each move, right, roll a six-sided dice, right? So this is a dice, right? So there is each side has a mark like 1 2 6 1 2 3 4 5 6. So you will get till the 6, either you will get 1 2 3 4 5 or 6, right, from this dice. So when you roll this dice, you will get a number, right? So that is the meaning of this thing. Means what we need to do, we have to start from the square, the first square, that is called square 1, and on each move, right, means when you roll the dice, right, when you roll a dice, this is a six-sided dice, so you can move up to 6 spaces forward, right? So if you land on the square, that start a ladder or snake, means if you start, let's suppose you land on a square. Let's suppose this is the square, right? You land on the square, and the ladder starts from here, right? When means when the starts a ladder, right, you will reach to 15, right? And if there is a snake is what means, let's suppose the board having row and column, let's suppose will reach to the 17, right? So board at this row and column will say not equal to -1. If -1 is there, means will reach to the 13, right? You must move to the that square from where the snake starts, right, like that. So you have to think like that, right? And our goal is to reach the final square, means 36, right? We can say n square, n is 6, right? So n into n is 36, so n square is 36, and in the least number of moves, so if we'll take the very least number of moves, then we will reach to the 36. That moves we have to return. If it is not possible, not feasible, return -1, right? And so if you think what we should use, right? So it is like a graph, right? We moving from each side one by one, right, like that, and then we reaching to the 36, right? So we will use BFS, and because each dice roll represents one level on the search. So if we'll move the dice, right, so there can be a possibility that each roll will move one level at a time, right? So that we will see further. Numbering, like we have from 1 to 36, we have like that, right? So this is just a fancy word of zigzag, right? Like you can see here, right? This like that. So you will start from 1 and we'll keep moving. You can move in the zigzag form also, right? So if you land on the ladder or snake, it means if the board contains row or column not equal to -1, means you are moving to the next square, right? Like that we have seen in the snakes, right? So we'll keep rolling, right? Player will move to the square and will jump on a ladder, that we have to see, right? And that is a representation we have to do, right? And we are already aware with this Ludo game, right? And so the problem is actually a graph traversal. So each square is a node, and each dice roll creates an edge to the next 6 nodes, right? So we'll use breadth first search to find the shortest path to the square n square, and we can convert this board first. Let's suppose you will convert this board, and we can convert into a, you can say a board, right? So the board can be converted into a graph, right? And if let's suppose so there is one, right? So we'll move the dice, right? So the dice can be dice can come any board will come, right? Any number will come, right? And so we'll move to any number. Let's suppose it come 2, it may become 3, from 2 it may come 5, like that. There is a possibility that we can move. So we can say that, so this problem is actually a graph traversal, right? But each node we can think like each square we can say like a node, and each dice rolls create an edge, right? Each dice can create as a you can say edge, right? And so the six nodes we have, so we can represent like this. And so we'll use this BFS traversal because it looks like a graph, and we can use the shortest path algorithm to find the n square square n square, the last one, right? So let's convert the board first, and we'll move further in the example. We can from 2D array we can we'll do the flatter process. We'll move to the 1D array, right? We can move it, and then we can convert it, right? So once we will convert the 2D into 1D array, right? So it will be easy for us to implement that. So what we have given, we have given n cross n boards, and we have, if the board row and columns is coming, it should not be the -1, right? So it start as a ladder or snake, right? Like that we will get it. Okay, so each move we have to do on we have to move to the final destination, that is a n square, and if it is not possible to reach there, we'll return -1. So if we reach to the n square, means it should be the least number of moves, and that moves we have to return. If not possible, return -1. Okay, so these are the approach that we are going to use in this program. So in the step 1, we will convert the 2D board to 1D array, like I have shown you, right? And that represent the each square from 1 to n square. And then for each step, right, we'll convert like this, and then we'll move to the next step, right? So we'll use further the BFS and BFS for this game, and for each square we'll try all the rolling 1 to 6. If we land on the snake or ladder, we'll jump to its destination. Then we'll track visited square to avoid the infinite loops, and then we'll move if the first time we reach the square n square, we'll return the number of moves, right? So this is very easy steps. You can pause it and you can try by yourself. So let's understand the flatter the board. How we'll do the flatter the board? So how you can move the n square board into 1D array. So let's suppose this is called moves. So from n square board, you can write n square plus 1, and you can move into the moves. The moves will be the array like a board. So this is the flatter board, we'll say, and we will first fill the value with the alternate left right and right left directions. So let's suppose we'll take moves. We'll initially will fill -1, -1, -1 like that, and then 35 like that. There will a possibility we'll do that, right? And when we flatter the board, right, so it will become easier, right? The traversal will be easier, right? So we can take a queue, or you can say we'll provide the first node, and then we'll mark it as a visited, right? So if the queue we have added the first one so we will mark the visited at 1 is already true, and then we'll move to the next one, right? Like that we know how to traverse in the BFS. So we will do the BFS setup, like you know that from the square 1 we have already start from the square 1, right? So we'll make a while loop. We'll say if it is not empty, the queue is not empty, but we added all the queue because we have started from the square 1. So queue is not empty, so we'll come to the for loop, right? So for square, we'll take the its neighbor node, right? If neighbor node is not there, right, it should be there. So from the current, right, we'll get the next current plus I will do, and we'll get the next, because all the moves will be there, and we'll have the I value. So each time we will get the next. How we'll find the destination? Moves at next should not be equal to -1. Then we'll go to the moves. Otherwise, we'll get the next. So for each move, we'll do the roll dice, and we'll jump through the ladder or snakes. And then we only visit each square once to avoid the cycle, right? Further, we will use a queue to do the BFS, and we'll start from the square that we have seen. So how we are going to write the code? Let's suppose this is your queue that we have added, the first square we have added on the queue. So we'll get the current. That current is nothing but the square 1. Then we'll the dice will add. So dice possibility can be 1 to 6. So we'll do that. You will get the next board. Next board how we will get current plus I will do, and then we'll check if next is not greater than n into n, means if we not reach to the last one, right? Last n 36. If we not reach the square number 36, it means if we reach there, if it is greater than that, it means we will break it. We will not move further, because we'll go out of the Ludo. You can say the board. If destination equal to this, moves not equal to -1, we have some moves. Otherwise, we'll move to the next. If it is not visited, mark it as a visitor first, and then add into the queue, right? And so we'll have the distance of destination and equal to distance of current plus 1. Just we'll add one more of each time, and we'll have our distance updated, right? Like this we will keep moving that. And so let's understand the code here. So first of all, what we have given this function, and we have to return the moves, right? You have given this board, so you will get the n, right? N is the number of boards, right? Number of board length, right, you can say. And you have to flatter the board into 1D array, as you know. So moves you will we have to do the moves, right? So n into n plus 1 will do, and we'll fill the array like this. So initially we'll fill the array with the -1 as I told you, right? And then we'll take a left to right, means we have to go for the zigzag. As you know, the BFS tree, right? We used to go the you can say zigzag form. I'll create another video in the our FANG preparation series, right? And I'll add there. Okay, so we'll go from left to right, that is a true, right? And if it will mark as a for the zigzag, right? When we are going by zigzag like this, right? So from left to right, we'll mark as a true. We'll go for n minus 1 to a row greater than 0, row minus 1, and we'll have if left to right we are doing, we'll have the column 0 to n, and with each move will update the level plus plus, and you will have the board value, the data, you will get the data from the board, right? So each moves will update here. Similarly, if it is not left to right, means it is right to left, means we'll update like this. Okay, row and col. And then we'll do left to right not equal to left to right, right? Like that we will do, means from the zigzag you will get the board data from board, means row at column you will get, right? And then you will have the moves data. Similarly, you will get from the board, if it is not left to right, means it is right to left, then we'll get from the board data and we'll update our moves. So your moves will get updated, right? We are moving for each level, right? You see, so we are increasing the level here, right, each time. So if it is left to right, we'll get from here. If it is right to left, we'll go from here, right? You pause this and understand here. Now we have already know how to do the setup, right, from the square one. So we will define the queue visited, and we'll add the square one on the queue. We'll mark it as visited, and we'll start the steps. So number of steps we'll define it. Then we'll do the BFS. As you know how we'll perform the BFS, we'll get the size, right, queue size, and we'll go for all the sizes. Then current, we'll get the current from getting the poll, right? And if we reach the last, right, we'll return the steps, right? If we reach the square 36, we'll return it. Otherwise, we'll go from I1 to 6, right? And we'll make a condition of this one also, and it should not be exceed that. So each time we'll get the next from the current, we will update the destination, right? And if it is visited, if it is not visited, mark it visited and add into the queue, and thus you increase the steps again, right? Like that you will do. If we are not reachable, a step will not get counted, will return -1. I hope you understand, guys. Let me know in the comment box that you understood, and thank you for watching this.
Thank you for watching this video. If you found this video helpful, please like, subscribe, and let us know what you want to learn next in the comment below. And thank you for watching this video.